Coming to you live from Seattle. I'm Mads Torgersen, the lead designer of C#, the language at Microsoft.
Hi, I'm Dustin Campbell, waving hello from my home office here. And I am an architect on various .NET developer experiences inside and outside of Visual Studio.
He also helps with the C# language design, so
that's
a little
right.
modesty there, a little modesty.
That's right.
Okay, well, we have this talk called C# Today and Tomorrow, and it's not just because we're giving it today and tomorrow. It's also to focus on both the C# 8.0 that recently shipped and the C# 9 that is about to ship. However, in this live version today, we will only focus on the latter, the today part. You can look at the pre-recorded companion video that we already made for you. And let's focus today on what's coming up in C#.
That's what they're really interested in anyways, right?
Right.
They want the cool new things.
Yeah, they don't want to sit around and listen to all the known stuff. So yeah. C# 9, the plan is that we ship it with .NET 5 in November. That's still November, I believe. And we always have like a multitude of features loosely clustered around some themes here. I think that roughly speaking, if I want to summarize what C# 9 is about, there's some stuff on simplicity in general, making your common scenarios easier to approach. And there's a particular focus on data and on immutability, representing that well. So without further ado, why don't we just jump into Visual Studio and get cracking?
Yes.
Right?
All demo.
Yes, my favorite slide tool is Visual Studio.
Yeah. Before you get going, Mads, one thing that has really bothered me for quite a while, I'm going to say since C# has existed, and it's that there's just kind of so much ceremony. It seems like I have to ask to do everything, or I have to put everything in a way that the compiler feels happy. I know. And this is a nice little console application like we would normally have for these sorts of demos. But that's where the meat of it is. It's right there, what you selected. And I don't want to say class. I don't want to see static main. These are the worst things when you're trying to teach somebody C#, because you have to explain, okay, well, no. Or you have to actually, what you have to do is say, don't worry about that. Let's get into the method body where we can start working. Oh, did you just delete those?
I deleted those. Yeah, so... awesome. Nice fake surprise there, Dustin. As of C# 9, you don't have to write all that boilerplate. You can just put the main program directly as a sequence of statements at the top level. Do whatever using you need to do, write your program, and then you can put some classes or namespaces after if you want to, including even local functions from the main program here. Just slap it all in there, and you have your main program.
Okay, but that's a local function. It's not like I can't call that from other things, right?
Right. Okay. But this is that was essentially, apart from the other two runs of this talk, this is the last time I will have program main on stage. I will just write my program at the top level. And this is not just for beginners where you have to explain 20 things before they get to actually do something, before they get to say hello world. It's also just the code becomes simpler, easier to navigate, less indented.
Yes.
So simple, but really nice. And you can do, to be clear, you can do the usual things you can do in a main method. You can write a wait and treat it as async. You can return an error code if you want to. And we actually, even, it doesn't work here yet in these flaming hot secret bits that we're showing, but you can even reference args as a magic parameter if you want to get at those command line arguments. So
fantastic.
Wish granted. Anything else bother you here?
Yeah, a little bit. So one of the things I see what we have here, we have this person class, and it's got these public auto properties on it that allow me to construct that without actually using, having to pass arguments to a constructor. I can allow it to use the default parameterless constructor and then use object initializers to an object initializer to just initialize that. And it's got this really great kind of way of giving me the object and showing me the initialization. It has a very, very, it just reads really nicely for me. And I'm not dealing with constructors as well, right? I can just keep on adding properties and I can add them in here. But one of the problems I have with this sort of thing, and I love it, but it just means that that it's got to be mutable, right? Some rogue programmer, somebody nefarious, I don't know. I don't know who that might be, but somebody who could come up and you could just set the last name, right, or set some property on there. Just it boggles my mind who would be that. Oh yeah, no, that's good. That's good.
Yeah. So
yeah, you could imagine that sort of thing happening.
right. So
And
in order to use object initializers, they work by assigning into the already created object, and so you need the object to be mutable, and you sort of sacrifice that. If you wanted an immutable object model, you can use object initializers. If we delete, let's do it down here with the last name. If we delete the setter, well, we prevent the prevent the rogue from assigning to it after, but we also prevent the object initializer. So it's kind of a shame. So in C#9, we actually add a variant of the set accessor called init, which does exactly what you want, Dustin, because it is an accessor that is like a setter, except that it can only be used during an object initializer. So while we're still doing the object initializer, these things can be set. Let's do it for the first name as well. But after assignment is prevented, you can now build immutable objects using object initializers, and without having to, write a constructor here and everything.
That is fantastic.
So, yeah, that is very cool.
If say I did want to set that value, I worked on Roslyn for a long time. The Roslyn APIs, they had all these with methods, right? So when you would work with them, so that because the data was immutable, and you would use a with method to set some value by creating a new object, a new instance of that object, and that had shared data with the previous object, and then set that one value. Can I do that with these then? Is there?
So
I guess I could add all those with methods, right?
You could, but you're really talking about using objects more as values, right? So you're talking about objects that where the identity and state don't matter so much, but they're more like a value representing a snapshot in time and an immutable one. And if you want to create a later snapshot at a later time, you want to create a new object that's like the old one with something changed. That's sometimes referred to as a non-destructive mutation. And you can use with methods and other patterns for that. But we really want to support that first class in C#9. So you can now put a keyword onto a class declaration and turn it into what we call a record. And when you make a class of record, that means we start treating it as data, as a value. And what that gives you is, among other things, the ability to do non-destructive mutation supported by the language. So what I can do is I can say var other person equals, and instead of assigning here, I can say person with, and then an object initializer, like syntax here. I can actually put an object initializer in this with expression. And now what I get is a new person that is just like the old one, except the last name is changed to Henselman. So if we go and display that second person, display other person, then we can, if we have the patience to wait for the compile here, we can see that we have in coexistence at the same time, we have the state before and the state after. So if you want to do explicit state management or undo patterns and everything, this is a really awesome pattern.
Oh, okay.
Whereas with mutation, you lose track of what the world looked like before.
Okay. So and can I set multiple things in there if I wanted to as well? Not just one thing.
Okay. You can set as many as you want. This is like an object initializer. So anything that can be set in an object initializer can also be set here. So I could say first name as well and so on. I'm not going to. So that's one sort of value aspect of it that was introduced by it being a record. This data keyword here introduced the ability on the class to support with expressions. Another value-like thing is that when you don't care so much about the identity, but you care about what's inside is what defines it. Sounds like a good principle to live by anyway. You want to have a different notion of equality too, right? So essentially you want value-based equality, where equality of these records is about equality of their elements, of their properties. And so we could actually go and create we could go and create an object just like the first one, original person. If I could spell, equals other person with, and now we can change the name back, last name Hunter. That.
Yeah.
And now if we write out right line equals.
Oh, sure. I see what you're doing.
Oh,
I want to put a quote on that string.
Yeah.
It's not optional.
That's details. Some things are still mandatory in C#. Some boilerplate is necessary. I can say equals. This is the static object at equals method of person and original person. Original person. There they are. And write that out.
Yeah, and you should show reference equals 2 to show that they're different.
We can do that.
Different objects. Yeah.
Yeah. So
let's copy paste that.
Copy this. Paste it in. Say reference. Reference. Spelling doesn't matter so much there, but it matters here. All right.
There we go.
Okay, let's try to run this.
So that should be true and false, right? Because it's value equal, but the reference it's not reference equal.
Exactly. Yeah. So now we have value-based equality generated by the compiler. It will say, okay, they're not the same object, but they have the same values, so it's good. So that's really sort of that's the essence of what it means to be a record. Now, when you look at it, I actually find this looks, one of the nice things about relying on object initializers is you don't have to write any of the construction goop, like there's no constructor boilerplate or assigning things back and forth and so on. But some people would still claim, some people, have languages where data types are much shorter than this still to express.
Well, right. I mean, we've talked about this a lot, in that, it's we always penalize in C#. We've penalized for years when you want to do immutable things, right? It's always just a little bit wordier. And in this case, we've added one character between the immutable version and the mutable version. So if you could get that shorter,
you should have called it ini instead. Then it would be the same.
Then it would be fine. It'd be the same. But, but we want to get it shorter, right?
Yeah. So we took a bold step and said in a record, you know what? If you just put type and name and identifier, we are going to change the default of what that means in a record. Instead of that meaning, private field, it now means public init-only auto property. Okay, so this means what I just had before. If you want it to be a private field, you can just put private in front and it's a private field again. But like this, it actually means, well, it doesn't in this prototype, as you can see, it doesn't get public.
Right.
But in the final bits, this is going to mean a shorthand for declaring those. So you can actually, you can make it a nice, let's start here and just start hitting the delete button. We can make it a nice one-liner, right? You can just contract express your data type, really a data type here, as just a one-liner type here, unless you want to stick out the things in the body, which you can. But so this is really, this is sort of an essential record. But it's very, I mean, it's what we call nominal in a sense, right? It only, it's based on, you always have to say the names of the members when you want to access them. Sometimes for small types in particular, it's nice to have a constructor, and it's actually nice to have a deconstructor as well.
A deconstructor would be weird here because there's not really an order, right? To the properties, yeah.
Right, but as soon as you have a constructor, you put an order on. You say the arguments have to come in this order, and now you can use that same order in a deconstructor if you want it to be more ordered. And you could just put a constructor and a deconstructor in the body of it, but there's a shorthand for that too, which is if you want the trivial constructor and deconstructor, you can actually put that quote-unquote constructor parameter list directly on the class name itself, and then give your body, or if your body is empty, I guess we will just let you write a semicolon here. And now you declare it the same type as just before, but additionally, it has a constructor and a deconstructor. And of course now, I'm not going to go and change it, but of course now the constructor takes 2 parameters. So I can no longer just do this with object initializers. I have to pass them as constructor parameters, which is part of the inflexibility, but also brevity of real constructors. So that's pretty much what I want to show in terms of records here in the demo. I think one thing to note that I'm not going to show right now, but I think that's very important, is that these this non-destructive mutation with the with expressions and also the value-based equality, these are things that it's important that they work well also when you have inheritance hierarchies, right? Because the way you describe families of types in an object-oriented programming language is with inheritance. You have maybe an abstract base class, and then you have several different kinds of things it can be. And all of this works across all of that, and across the subtype polymorphism that inheritance enables.
Right. I think that's something just kind of from a design point that we think about a lot, right, on the C# language design team in general, is that, you know, when we're borrowing these kinds of features, especially a feature that's rooted in a very different sort of paradigm, like a functional programming paradigm, like records are typically associated with, we want to make sure that they feel at home in C#, right? We want them to be, you know, to kind of compose well with the rest of the language. And in an object-oriented language where there's inheritance, you know, and it's kind of open-ended inheritance, whereas in functional programming you might have these in a discriminated union, which is more of a closed set, right? But to give an open set of types that can be inherited from, and then still get value equality working, even when the types don't look the same, or you're talking to a person, but really it's actually some subtype of it. It's actually a student at runtime, and still getting that value equality working, still getting all of these features. That's and with and things like that, so that with will construct the correct object at runtime, the correct type of object. I think that's really, it's just an important design point. It's actually what's taken us a while with this particular feature.
It's been a big part of it to make to not just take records as they are in some more functional oriented languages, but to integrate them deeply into the object oriented paradigm. So I'll leave you with that for records, and then just before we take it over to Q&A, let's just take a very quick look at some of the other stuff we're putting into C# 9. One of the things that we've been turning the crank on several times since C# 7 is pattern matching.
This keeps on giving, man. This is
it keeps on giving. And, we've added. This is a snippet from actually the example that we used last year at Build, and also it's a tutorial on Microsoft.docs.com about pattern matching, which is really great. But we've made some new kinds of patterns to help here. One is that whenever you want to match on a type, you can just say the type. You used to have to also give an identifier. That's just a little syntactic improvement there. But we have a couple of new kinds of patterns as well. One is a relational pattern, where you can take the usual relational operators of C# and you can now use them as a pattern. So less than 3,000 is now a pattern, and it matches any int that's less than 3,000. And you see that used in a few places here. We also have what you call logical patterns, where you can compose patterns with and, or, and not, just like you can expressions. But to make them stand out from expressions a little more, we decided to not use the usual symbols for it, but to actually spell out the words and, or, not. So here I'm creating an interval by anding together 2 relational patterns, and down here I think this is the most what will be the most common use of the not pattern, which is not null. You know, here I can differentiate and say not null. Then I know then I can throw an argument exception if it's null, I can throw an argument null exception here.
That's going to be beautiful in is expressions, right? You know, I am tired of typing if parenthesis bang parenthesis, you know, P is customer, right, to negate the whole thing. But now I can say P is not customer or is not null. I can do those things. That's just awesome.
That's going to be nice. And a few more things. Target type new. A little useful feature where you can simply leave out the type in a new expression if the type is given from context. Simple as that. So sometimes you find yourself writing these long big types that are generic and everything, again, just after having set them, or them being the parameter type or whatever. You can now avoid that. Parameter null checking. We want to check your parameters as they come in, whether they're null, throw an argument null exception with the right thing. We want to do that for you with a simple syntax instead of you having to spend half your business logic or having to do all this before you even get to the interesting part of your logic. That sort of ties in with the nullable stuff we did in C#8. And finally, I want to mention covariant returns, where we let you specify a more specific return type, more derived return type when you override a method, so that you can get a better static type of that. If you call it and you know you're calling it on something that returns a student, you don't have to cast. Little useful things like that. With that, we want to give it over to the Q&A. You should consider taking a look at C#lang, which is the repo where we do a language design. Over in Roslyn, there's a lang status page that we put an AK link for here that can tell you where we're at with the C#9 features in terms of implementation. So with
Fantastic.
that, let's get to a few questions from the crowd out there that hopefully is there.
Yeah, we have a few questions here. We have some that are on. I mean, they came in throughout, and so we have different ones. Let's talk about a couple that came in around top level statements. There were just a couple of them, and the first was how to get the arguments array, and I think you answered that actually when we said it, but it might have gone by too fast. And I mean, if you want to go ahead and say that again, yeah.
We can go into the. So I can't do it yet, but the answer is I can simply say args, and args is a magic variable, just like value in a setter accessor. It's just a name that's in scope, and it has args, because 99% of the time args is what you were going to call it anyway. That's what the templates put in, and in a main method. So
right. So the idea is that we want to kind of see what you're doing in that constructor body and surface things that would be natural to write in main. So args is available. Like Mads had said earlier, if you write a wait, that makes it an async main automatically, things like that. So it should work for the most part. That's our hope. Yeah. There might be some weird corners, but it should just kind of work.
Yeah, the idea is we don't want it to be sort of a poor man's main where you sometimes you have to fall off the cliff and actually go into a real main. We wanted to just give it the same capabilities, and that's what we did.
So let's actually switch over to some of the record stuff. We had a question from Joseph S. Asking how deep is the copy in the object, right? So like how are arrays and enumerable properties treated when we use the with expression, I think is what we're referring to here.
Yeah, it's a shallow copy. So it copies field by field. It will do an assignment, essentially what corresponds to an assignment of the fields. If you want to,
in a way, it's like thinking about a struct, right?
Yes, yeah. Actually, the way we decided on the copying semantics for the with expression and the value equality semantics is that we looked at what structs do, and we do the same. So we don't want to create these slightly different semantics in the same language. We just said we do the same as structs, which is field by field, all the fields shallowly. We call equals on all the fields when we do equality, and we just do assignment on all the fields when we copy for the width. There's actually, if you don't like that, obviously you can overwrite the equals method yourself. That's a virtual method on all objects. But for the with method, you can't overwrite that directly. That's compiler magic there. But we generate a copy constructor and then call into it. And by copy constructor, we mean a constructor that takes an old object, like the old person as an argument, and copies it over into this new object that's being constructed. And that one, if you write one yourself, we will use that one instead of generating one. And so if you want to get in on how exactly to do the copying, you can do, that's where you plug in. You can do that.
Let's see. Another question that's come up here. Actually, let's see, 1, 2, 3, 4 times so far. Yes, is around serialization and init setters, and how will these work? Right? Can I write an immutable type that is serializable and can be deserialized? Right now it's not really possible because you need to have public setters in certain cases and things like that. So that's the question. Well, how will this work with serialization? Yeah.
Yeah, we're still, I mean, many serializers just jam things in and they don't even respect read-onliness. And so they will just continue to work just fine. I think that the main point here is that the thing that stops you from assigning later is a compiler analysis that that probably won't be present by default when you do things through reflection, and so they will probably continue to work just fine.
Right. I think the thing is here is that these are still setters, right? These are still property setters, but we have protection on these property setters now so that you can't just mutate these objects. So in deserialization, it should deserialize as it always had, right? And setting these should work fine. There's nothing happening at runtime right now to really affect this. That might happen some point, but not today, because that's a big pill to swallow, right? That's, you know, getting all the serializers in the world to just work is hard. So so we're not tackling that because we don't like to do hard things, or we do like to do hard things, but they take us several releases. And in this case, you know, since they're just setters, they just continue to work, but you get, you know, you get compiler enforcement around not being able to set those in source code.
Yes.
Right. So you don't have to take the cost of like, well, I want to use serialization, so I'm adding, you know, mutable properties on here. Well, now you don't have to kind of swallow that pill and have to kind of go along with that.
Right. If you think about it, if you sort of squint a little, deserialization is sort of like a reflection object initializer, right? Create the object and mutate it, just like an object initializer. I don't want to keep seeing that. Okay.
Yeah, I don't think so.
All right. We can take, I think we can take one or two more questions.
Okay. Let's see.
4 minutes left.
Let's see. There are a lot of questions here. Well, an example, well, actually, this is a really good question. So when we're talking about inheritance, basically, would records, and the question here is from Katarina F., would data classes or records, would they need to derive from other data classes?
The way we discussed this a lot, and the way we currently envision is they don't have to. If you derive from one and you're an ordinary class, well, you just inherit whatever they have. You won't be able to do everything in person, though, or sort of manually that they do. For instance, the width support, you won't be able to add to that in a meaningful way. So typically, I don't think we will enforce this, but we might change our names. Typically, if you derive from a record, you are also a record. Unless sometimes the reason we're leaving it open is sometimes, you know, you want to have a derived class for implementation purposes, but really sort of conceptually, as seen from the outside, it's actually the same. You don't want it you want it to be able to be equal to its base class and so on in a way that records don't normally do. And I can see you using an ordinary class to derive from that. In that case, you want it to make sort of just a variant of an implementation-based variant of the record. But other than that, you want to derive records from records so that you can get that right chaining together of the equality functionality and the non-destructive mutation functionality.
Let's see, we have just a couple minutes left. We had a couple of questions around kind of init properties, and we showed them as auto properties.
Yes.
There are some questions about, you know, can they have bodies, right? Can they be non-auto properties, for example, and you know, and have do custom logic in there? I think this comes down to, you know, we want to be able to let you set these in an object initializer, but yeah, we want to also allow you it can still have complex logic, right?
Right. So I could have a private string last name here, and I could implement my property. Like if I want to have validation in my property getters and setters, for instance, I could totally implement them manually. Init is still allowed as an accessor there, right? So we could. I don't have time to do it, but yeah, I could go and give them bodies.
Yeah, and that comes from Nick M. And then one kind of related question is, can I enforce required parameters and constructors and then have, like, say, optional init, you know, sorts of properties here as what in this kind of the shortened syntax? Can I kind of mix and match that sort of thing? That comes from Aaron C.
Yes, you can. Yes, you can absolutely mix and match. You can choose if you essentially, in this syntax where you have no constructor parameters at all, that is just the same at, let's put data here. That's just the same.
Just don't get deep because I think we're out of time.
Okay.
So just don't get too deep because it's 2:30 right now. So just want to say thanks to everybody.
Yeah, if you're still there. Thank you very much.
If you're still there, thank you very much.